So now we're getting into arithmetic, those building blocks upon which algebra, geometry, and other fun stuff will be built in the course of this video series. Factors, multiples, and divisors. First off, some basic terminology we need to cover. An integer is a whole number, so positive and negative whole numbers. So numbers like, well, actually I will bring that up there. Examples include -3, 2, 0. Yeah, so the numbers the markings on the number line on either side of 0 and including 0. Not examples would be things that are not whole numbers. -3.5, 2 1/4, the square root of 2, things like that. Not integers. So guys like this, not like this. A prime number is divisible only by 1 and itself. So then that's the dictionary definition. And so they're always positive. They're always whole natural numbers. So they look like integers, but of course they're never negative. So they have two factors, okay, 1 and itself. So a prime number, for example, would be 3. The only two different numbers that you can multiply together to get 3 are 1 and 3. 1 times 3 equals 3. That's how you define a prime number. So a number like 6, which you could do 1 and 6 or 2 and 3, is not prime because there's 4 factors. Factors are the numbers that you can multiply together to get a bigger number. A number is always its own factor, as is 1. But primed are the ones that have only those two. So important questions. Are there any even prime numbers? Are there any numbers that are even that you can only divide by themselves in 1? I'll just answer that question for you. Yes, and standardized tests love the number 2. Remember, you can only multiply 1 times 2 to get 2 in terms of two different factors. So definitely an even prime number. Is 1 prime? Now, if you've been following along, our definition of prime is that the number has to have two factors, two different factors. How many numbers can you multiply together to get 1? Only 1, which is 1. 1 times 1 is 1. So 1 is in its own special case. It's called an identity, or you could just call it not prime like the rest of all the other numbers. But basically 1 only has one factor, which is itself. Is 1 prime? No. Is 0 prime? No. 0 is prime for the opposite reason. Since you can multiply any numbers together with 0 to get 0, 0 is also not prime. You need to have 2 and only 2 distinct factors for 0, where 0 could be 0 and 1 or 0 and 11 billion. Are there any negative prime numbers? No. Remember, part of our definition is that they're positive. Even a number like -3, you can multiply 1 times -3 equals -3, or -1 times 3 equals 3. So if you want to even introduce the idea of being able to multiply other things together to give you -3, it still has more than 2 factors. So no, there are no negative prime numbers. Okay. So here's an example of a number properties problem from the Grocket vaults. Which of the following integers cannot possibly be the sum of two prime numbers? Select all that apply. So this is a select one or more answer choice question. And so there's going to be at least one, and it could be all of them, in theory. So we already established from the previous page that a negative number can't be prime. And the only way you can get a negative number by adding things together is if you're adding together negative numbers at least once. So like you could have 4 plus -7 equals -3. But in that case, this can't be prime and this isn't prime. You can't even do 1 plus, or 2 plus -5. Because even though 5 is prime, -5 is not. So can't be this one. This one cannot be the sum of two prime numbers. So that's one of our correct answers. What about 3? What numbers can we add together to get 3? We can add 1 plus 2, but remember 1's not prime. We can add 3 plus 0, but remember 0's not prime. So this actually is another one of our options. We could add 1.5 and 1.5, but those are also not prime because prime don't have decimals or fractions. So 3 is also a number that cannot be the sum of two prime numbers, and therefore it's one of our answers. What about 8? Well, 8, it could be 3 plus 5. 3 and 5 are both prime numbers. It may help you when you have a prime question, if you're not as comfortable with primes, to memorize the first few prime numbers and then write them down. So the first few prime numbers, 2, 3, 5, 7, not 9, because 9 could also be 3 times 3. If it were only 1 times 9, it would be prime. But since 3 times 3 is another way to get 9, it's not prime. However, 11 is prime, 13 is prime, 15 isn't. All the rest of these are odd except for the first one. But 13 isn't, or 13 is, 15 isn't, 17 is, and so is 19. Anyway, there's more of them. You know, in fact, nobody even knows how many there are. In theory, they're infinite. But knowing these first few, especially the ones up to 10 or 11, really make your life easier. So 8 could be 3 plus 5, 2 numbers on our list. D, can we get 2 numbers on our list to be 9? Well, 7 plus 2, that's 9. 7 plus 2 equals 9, 3 plus 5 equals 8. So since it can be the sum of 2 prime numbers, it can't be the right answer. We need the ones that cannot possibly. You know, we could do it so that it's 2 not prime numbers, you know, 1 and 7, but it still could be this other one. Or sorry, like 5 and 4. That would be a naughty one. Anyway, so not C, not D. 18, well, we could do 5 and 13. 2 more prime numbers, and since we were able to come up with a way for 2 primes, it's also not the right answer, leaving us only with A and B. Some other number properties to talk about. Negative times negative is always positive. Just remember it always is. Positive times positive is also always positive. It's only when you have a negative times a positive that you end up with a negative number. So memorize these if you have any spare brain space. These are absolutely mission critical to getting so many questions right on the test, on the quantitative side anyway. So negative times negative, positive times positive, both give you positive. Only negative times positive gives you negative. So putting that into practice, so which of the 3, and we actually did this, we had this as an example of a choose one or more answer choice when we were doing our sample problems. Which 3 of the following integers have a product that is less than negative 85? So remember, less than negative 85 means more negative. Like if you have negative $85, that's more money than negative $185. They're both not good amounts of money to have. But negative 85 is smaller, or excuse me, greater than something that's more negative. Anyway, so we need a big negative number. How can we get a big negative number? And we have to do it with 3 numbers. So knowing what we just learned about positives and negatives, to get a negative number at the end out of 3 numbers, we either have to have positive times negative, or we need to have negative times negative times negative. Anything else will give us a positive number. If we do plus plus plus, that's positive. Also, if we do minus minus plus 2 negative numbers, these 2, negative times negative is positive, and I could turn that into a smiley face, I guess, turns into a positive number. So it has to be one of these 2. Now there's only 2 positive numbers in our list, so let's try this out first. So this would be 7 times 2, and then we need a negative number. We're trying to make it as big as possible. We're trying to make, you know, the number part of it big because it has to be more negative than negative 85. So our biggest one is negative 6. So 7 times negative 6 is negative 42 times 2 equals negative 84. Just a bit shy. Negative 84 is actually greater than negative 85 because it's less negative. Anyway, we needed something like negative 86. So it's not positive, positive, negative. The only other option then is negative, negative, negative. We can get rid of these 2 answer choices just by doing that. And now again, we still want as big a number as possible, so we choose our 3 biggest ones, 6, 5, and 4. Negative 6, negative 5, negative 4. Negative 5 times negative 4 becomes positive 20, but positive 20 times negative 6 becomes negative 120, which fits the bill of being less than negative 5. So it is these 3. Evens and odds, another set of things that really you do need to memorize. I mean, I'm sorry to tell you that. Nobody likes to hear that they have to memorize this in addition to learning words and grammar and stuff. But, you know, your ability to prepare for this test is one of the things that graduate schools are testing. So commit to memory the following. Even times even is always even. Even times odd is also always even. It's only odd times odd that always gives you an odd number. If ever you're not sure about these rules, you just, whatever reason, just pick numbers like 2 and 3 and test them out. So even times even would be 2 times 2 equals 4. Yeah, it stayed even. Even times odd, 2 times 3 equals 6, stays even. Whereas 3 times 3 equals 9, it stayed odd. When you do even plus or minus even, so let's say 4 plus or minus 2, 4 plus 2 is 6, 4 minus 2 is 2, so even plus or minus even stays even. Even plus or minus odd, so let's do 4 plus or minus 3, so it's either 7 or 1, both odd. So this one is odd. Odd plus or minus odd. Again, let's do 5 plus or minus 3. We get 8 or 2. So odd plus or minus odd is even. Again, whichever is easier, I guess. Either memorizing these rules or being very comfortable just reinventing them, re-engineering them, re-deriving them on the spot if you have a problem that involves these things. So, but I think they're worth being very comfortable with no matter how you do it. Properties of 0. Is 0 positive or negative? Neither. If you look at a number line, pretend that's a line, 1's here, negative 1's here, all the negative numbers start at 0 and move that way. All the positive numbers start at 0 and go that way, but neither of those includes 0. 0 is neither positive or negative. It is neutral in all disputes of the cosmic struggle between positivity and negativity. Is it odd or even? Now this one, it does actually have a value. Because it is one of these even, I gave it away there, because it's one of the intervals on the number line, so like here we would have -2 and here we'd have +2, so this is an even number, an odd number. This must be an even number because we alternate between evens and odds on the number line, even, odd, even, odd. So because 2 and -2 are even, and then you have odds before it, 0 is considered an even number. 0 times any number is going to stay 0, whereas 0 plus any number will stay that number. So 0 times x gives you 0, but 0 plus x gives you x. Any number divided by 0 is undefined. If you think about it, you can put an infinite number of zeros into something because you're putting nothing in. You can do that as much as you want and it doesn't change the value. So if you have a savings account with $100 in it, you can make $0 deposits all day for the rest of your life and you'll still have $100. But it's undefined how many times you could really do that. So maybe that doesn't help you remember it. But just dividing by 0 is naughty. Maybe it helps if I just write that. Dividing by 0 is naughty. The GRE will not do that and will go out of its way to avoid it. I'll show you what I mean. All right. So the order of operation, PEMDAS, if you can't remember PEMDAS, there's a mnemonic device. Please excuse my dear Aunt Sally. You can come up with something funnier or naughtier if you want, as long as you remember it on test day and actually while you're doing your homework. This represents the order that you should do things. If you don't do operations, a complex thing like this guy here, if you don't do it in this order, you will get a different number and that number will be wrong. So the GRE is expecting you to have this internalized, memorized. On test day, you do parentheses. Anything that's in parentheses you do first. Then you do exponents. Then you do multiplication and division in that order from left to right. Technically, they can be done in any order. They're whatever that property is, commutative or something like that. But if you want to be consistent, make sure you don't miss things from left to right in that order. Same thing with addition and subtraction. That can, you can do them individually, but it is best to do it just from left to right to keep yourself straight. So do it in this order, otherwise bad things happen. So we would do the stuff in the parentheses here first. So this just becomes 5x quantity squared. Then we would do the exponents. 5x quantity squared becomes 25x squared. And then we would have 2 times 25x squared plus 6x minus 3 all over 3. Then we'd go from left to right to the multiplication. This then becomes 50x squared. And then we have like this factory thing that we might have to deal with. Anyway, that's how that works. Memorize that. Sorry to keep telling, not everything that I'm going to be telling you is memorized stuff, but There are some basics that are considered fundamental to the rest of the exam.